Now, in this video, we're going to look at confidence interval for population proportion, P. Now, population proportion is a unique case. So far, we've been looking at general populations where we have a random variable, which is a continuous random variable, which can take any value within a given range. But when you're talking about population proportion, what we're talking about is success or failure is what is recorded in the population. That is, it either has a 0 value or a 1 value. 0 will be failure, 1 will be success. So it will be like when you're submitting a bid to your customer, whether your bid will be accepted or not, or whether there will be a sale or not. Okay, if you have a sale, that is success. If you don't have a sale, that is failure. Okay. So 0 or 1, only zeros and 1. Or it could be like in a population of graduates, how many female graduates are there? So female and male, only two possible values, and they are coded as 0 and 1. So in that case, the population is surely not normal. So we cannot just simply say, all right, we will use the normal probability T function and so on. So you have to now come up with a different way of dealing with the situation. So what we have here is the population proportion P, and for which we want a confidence interval, and it has the same format. Your point estimate is P bar, and then you have the margin of error. So how do we find the margin of error? So it turns out that since you have only two possible values, and that kind of distribution is binomial distribution, so we can use the binomial distribution properties in our calculation of margin of error. But before we get to that, now we're going to be using the z distribution for the table value. So we still have the approximation. We're going to take the binomial distribution and we are going to approximate it with a normal distribution. And for that approximation to work, the sample size test is that n times p, the sample size times the proportion, and n times 1 minus p, they both must be greater than or equal to 5. In other words, there must be at least 5 successes, there must be at least 5 failures in the sample. Then we consider the sample to be large enough for us to approximate the binomial distribution with a normal distribution. Of course, the value of p will be unknown, so we'll have to substitute p bar in this formula. So once we have established that we have a large enough sample, then you can approximate the binomial distribution with a normal distribution, p at the center, and sigma sub p bar times z will give you the margin of error. So minus margin of error plus margin of error will give you the lower and the upper limit. So here is the formula for the standard error. Okay, square root of p times 1 minus p over n. Of course, we won't know the value of p, and therefore we have to substitute that with p bar. So the formula here for the interval estimate is p bar plus or minus z sub alpha over 2, and this is your normal table value. In Excel, we will use the norm.s.inv function to get the z value, and then p bar times 1 minus p bar over n under square root. So that's your standard error. So this part is now the margin of error. The z table value times the standard error gives you the margin of error, and p bar is your point estimate. So minus margin of error gives you the lower limit, plus margin of error will give you the upper limit. So that will give you the confidence interval for population proportion